Uh, Today we will solve the problem 2.27 of Griffith, third edition Introduction to Quantum Mechanics. This problem is a lengthy one, so I have divided it into two parts, and also it is very interesting, and I have solved in a very simple manner. So the problem 2.27 is consider the double delta function potential, that is v of x is equal to minus alpha times delta x plus a plus delta x minus a, where alpha and a are the positive constant. Sketch this potential. That is first question. How many bond does it possess? Find the allowed energies for alpha equal to h cross squared over ma, and for alpha is equal to h cross squared over 4ma, and catch the wave function. These two questions. First question we will solve is very simple. Second one we will solve the partially in this lecture, and the remaining we will catch the wave function in the next class. So here the question is sketch this wave function. We have the potential, y-axis is potential v of x. X-axis we have 2 points at a. Here this is delta x minus a. Here is a delta potential. Here is delta x plus a. So the wave function psi of x is equal to, we can straight away write in a simple manner, when if x is greater than a, that is outside this potential, delta potential, uh, that is after this delta potential, as since x is positive, you have a solution a e power minus kx, because it will go from up to infinite. So at the infinite, wave function has to vanish. So we have selected this wave function. The other e power plus kx we have removed. Similarly, between these two range, that is between minus a to plus a, what will happen? Here this wave function is, let us say, the same normalization constant for both this and this. So p in p times e power kx plus e power minus kx. Then this is x is between minus a to plus a. And then this is symmetry we have taken as even function. Delta function is a even function. Remember that, you keep it in your mind. And then in the negative x-axis, the wave function must be a e power kx plus kx. The minus kx, this is the general solution. In this condition, minus kx is not allowed wave function, because when x is negative, this will become positive. At infinite, this will shoot up. So it is not a valid solution. So the valid solution is a e power kx. This we have seen so many times in our lecture. Then we will move on further. And now we will consider only the positive x direction. In this direction, this the potential delta x minus a will be non-zero only if x is not equal to a. Sorry, only when x is equal to a. So when x is equal to a minus a 0, delta function 0, will have a non-zero value. So the Schrodinger wave equation for this problem is minus h cross squared over 2m t2 psi over tx2 minus, because this is potential, minus alpha times delta x minus a psi e psi. See this positive x direction, the delta function is x minus a. So this has non-zero value only when x equal to a. So this is the correct option. So we have selected it. Minus alpha delta x minus a psi, which is equal to e psi. Remember that there is a discontinuity at x equal to plus or minus a. Here one discontinuity, here one discontinuity. However, we have taken only the positive x-axis, even solution. This way, you have the wave function minus psi, there is a scaling factor only, which will not affect your physics part of it. So now the problem is if you first order differentiation, first order derivative is for infinite. So first order derivative itself you have infinite. This is derivative. So first order derivative is infinite. So it is very hard to find the second order derivative. So for that what we are going to do is we are going to integrate the first term between the range. Here you can see this is you take a small distance epsilon. Of course this is minus epsilon. Okay, I will erase this, and this one is plus epsilon. From A it is epsilon. This is minus epsilon. In fact, this can be correctly written as A minus epsilon. This is A plus epsilon. Epsilon is very small, tends to 0. So here you can integrate both sides. So minus h cross squared over 2m integral between a minus epsilon, a plus epsilon, t2 psi over tx to tx minus alpha. This integral will become between the limit a minus epsilon to a plus epsilon delta x minus a psi tx. Then the right hand side you have a minus epsilon to integration between a minus epsilon to a plus epsilon e psi tx. Now remember that you are taking almost close. This epsilon is very small, so the energy will be approximately it will tends to 0. So you can remove this portion. Now you can have you multiply this by minus 2m over h cross squared. So this will become 1 because we are multiplying by inverse of this. Then in the second term you will get the 2m over h cross squared. Already there is alpha and this integral portion, which is equal to 0 as we have seen. This is if you apply the limit, you will get, if you integrate second order derivative, you will get first order derivative, which is supposed to be a delta function. So first order derivative, this is upper limit, a plus epsilon, and minus the lower limit. Lower limit is a minus epsilon, which is equal to this will be if you integrate this, what you will get, you will have a non-zero value when only when delta x is equal to a. So psi of x here will become psi of a. So we will write this. This is the difference in the derivative. So I have written as capital delta t psi over tx is equal to minus 2m alpha over h cross squared psi of a. So we will reduce it further. And now we got this expression, that is delta, that is difference in the derivative of psi with respect to x is equal to 2 times m alpha over h cross squared psi at point A, psi of A. So now we can compare we have taken positive x direction as reference. So the positive x direction is x. These are the wave function between the which is greater than x is greater than a and x is between minus a to plus a. So if you compare these two equations, the wave function and its derivative must be equal. So first you take the case of wave function. A e power I ka is equal to, because at the point A we are referring, so at the boundary, so which is equal to p multiplied by e power ka plus e power minus ka. So now you bring this p to the left hand side, that is this side. This will become a by p, and you take this one, this exponential term, to the right hand side. So you have to divide this by. This will become a by p, and if you divide this over e minus ka, this will become e power 2 ka, and if you divide this over e power minus ka, then this will be 1. This is ratio between a and b, which we are going to use later. So next what will happen to its derivative? You take the derivative of this. So left hand side derivative, if you take the derivative, you will get minus k a, already you have a, e power minus ka, and left hand side you have p, and if you differentiate this, you will get k e power ka, and if you differentiate the second term, you will get minus k e power minus ka. So now what is the difference between the derivative? That is, this is left hand side. Left hand side, in terms of physics, I can explain. See, this is at the point A. This is A or greater than A, this portion. Let us say a red color mark, you can see. It is at the boundary A. So left hand side is at the boundary A. What about the right hand side? Right hand side is between minus a to plus a, this portion. So very closer to this delta function. That is a difference in derivative at the point A, and between this minus a to plus a is this one. Now if you like to find the difference, you subtract this and this. That is, you bring this to the other side. If you bring this, you will get minus ka exponential term minus p multiplied by ke power ka minus k e power minus ka. Now what I am going to do is, I can substitute it here. So left hand side is delta partial derivative of the wave function, which I am going to replace by this right hand side, that is a green color bond, this one. Then the right hand side I have minus 2 m alpha over h cross squared a e power here psi of a. What is at boundary? Psi of a is equal to a, capital A e power minus ik ka, because x is equal to a. Now you divide both right hand side and left hand side by minus k e power minus ka. So if you divide by, I can write specifically, you divide by minus k e power ka, then this will become plus, and this k will get cancelled. This exponential term also will cancelled. Here also this minus will become plus. Then this ka will get cancelled. E power ka will become, because we are dividing by e power minus ka, so this will become e power minus e power plus 2 ka. Then next term I am dividing by minus Ka. So this will get cancelled, and this also will get cancelled. So I will get a minus 1. Remember that I brought minus outside the bracket, so I have not changed this sign. So I have brought already this negative sign outside the bracket. So I am leaving this negative sign as it is. So this will become, here I have only a, here I have p, then e power 2ka minus 1, because both the term will get cancelled. So this will be minus 1. Which is equal to the right hand side also I have to divide by this k. So this will become plus, because I am dividing by minus k, then exponential term. So here I will get 1k. Here I will get k. And this exponential term will get eliminated. Exponential term will get eliminated. So I will get a plus p e power 2ka minus 1, which is equal to 2m alpha over h cross squared k. This k comes because of this one, multiplied by a. Now we will reduce it further. So finally we got this expression. Then you bring this a to the right hand side. This a, you can take to the right hand side. So this will become minus a. So if you take a as a common factor, you will get 2m alpha over h cross squared k minus 1, because if you bring this, it will become minus a. Then you bring this p here, then this will become a over p 2m alpha over h cross squared k minus 1. Then you replace a by p, ratio between a by p, we got it exponential e power 2ka plus 1. I have replaced this by 2ka plus 1, and this 2m alpha over h cross squared k minus 1. We will continue our discussion in part 2. Subscribe to my channel to get my latest videos, and join my channel to support its growth and enjoy the exclusive perks. Also use the thanks button to make one-time contribution and support my channel. Thank you very much.